So, hey students, good morning and welcome to our next session. Before we begin, as usual, let me know if you are able to hear me properly and see the screen as well. We'll begin right away. All right, perfect. So, so let us begin today. What we are going to start studying as of today will be entirely different. We will not take up MCQs and start solving MCQs. We'll instead go through as much as possible from basics of data structures. Once we are good with the basics of data structures, what sort of interview questions they may ask from basics of data structures, we will then go for algorithms. So let us start data structures to work with today. Now, whether it's data structures or algorithms, one of the common things that we need to know is asymptotic notations. So you have three notations. There is big O, also referred as big O, or omega, and theta. These are the three asymptotic notations you have. So here's how we define them basically. So, I assume there's I all right, there's no okay, there's no audio issues, I hope. Okay, all right, perfect. So let's go ahead. So these are the three asymptotic notations you basically have. Now, when you begin with this, the first thing you need to know is whenever you calculate asymptotic notations, you calculate time complexity in order to calculate it. You figure out what is the time complexity. So let us try to calculate by ourselves what exactly is the time complexity and what exactly is the space complexity, and how do we calculate it in our own programs. Now, you already know that O of any function, O of any time is specified as worst case time, and theta of time is specified as average case, and omega of time is specified as best case. So to start with this, what we need to know is time complexity comes up in the following order. So one thing you guys need to know is what is the general order. There is which is faster and which is slower. So whenever you calculate this, you can state first, you can call them as common time complexities or common asymptotic notations. Now, the first one is a constant one. This is generally referred to as big O of 1. The second one we have is logarithmic. This is bigger than constant, and you generally refer it as big O of log n. Log n is smaller than the value of n. I'm writing this in ascending order. Please remember, guys, everything I'm writing is in ascending order of time. So constant takes the least time, then logarithmic, then there is something called a linear, which pretty much exactly takes as guessed big O of n. Then you have again another logarithmic. There is big O of n log n. N multiplied by log n will obviously be higher than the previous two. Then you have quadratic, then you have cubic, then polynomial and exponential. So these are the common kinds of time complexities or asymptotic notations you have. So quadratic, as you can expect, it is big O of n. So big O of n power 2. So if big O of n power 2, how is it exactly quadratic? There are no other equations. So to understand all of that, why exactly we call it as cubic or quadratic, we will see how it may or may not have other parts in the same time complexity, which we will not specify as well. So let's go ahead from here. Now that we just saw which are the basic kinds of time complexities, I want us to figure out how to calculate it, or how do we figure out what exactly will be time complexity. Now, time complexities are not calculated by seconds, like my program executes in 0.29 seconds or my program executes in 0.56 seconds or something. Time complexity is pretty much that is how, if you can say it is common, or you can say it is something that is um, common in terms of time spent for all the computers. That is why we don't recognize it in terms of space. We recognize time complexity in terms of number of operations performed. This is how we recognize time complexity. Always by something called number of operations performed, and not by the actual time taken, because that varies from computer to computer. But number of operations performed, it does not vary from computer to computer, even though the time in seconds or minutes varies. So this is basically how we calculate it. So we know that number of operations, and not you can say time taken to execute them. So to understand this, let us just go through some basics of time complexity and space complexity, and go through it to get a better understanding. Now, once we go through time complexity, I want to take as much time as possible only in time complexity, because you will expect most questions only in this. But before we go on to time complexity, let us go on to something else called space complexity. So whether it is space complexity or time complexity, we generally state all of these using your asymptotic notations as well. Both space and time complexity are uh, identified using this. Now, if time complexity pretty much depends on number of operations taken and not time taken to execute them, any cases on what space complexity may depend on. See, for your entire program, it requires memory. Any program requires memory, and that memory allocated, exactly correct, that memory allocated will depend on three things basically. So those are variables declared, and program instructions or the exact code, and the execution of them, how exactly are you executing them. So this is pretty much what it depends on. So space complexity, in interview question, if you may expect this, um, if they ask you is what is auxiliary space, or what is input space, or anything like that, just remember, for now, for default, auxiliary space plus input space will give you space complexity. Based on these two, you will be able to calculate space complexity. So auxiliary space is where all the um, variables or temporary space, anything that requires space during the program running. While the program runs, however much space extra is created, there is auxiliary space. Then however much space is created to store the inputs, there is input space. Both of them together are generally used to calculate your space complexity. Now, let us let's say we will try to calculate space complexity of a couple of examples. Now, before we do that, to calculate space complexity, you need to know size taken by each variable. Now, for your space complexity, your question can be asked from C or C++ if such a question is asked. So you should know which variable takes how much size. So we know that a boolean takes size 1. Let me just write it as data type and size. You guys know that boolean takes size 1, and let's say char takes size 2, and whether it is signed, unsigned, whatever char it is does not matter. Signed char or unsigned char, all are pretty much the same. Then, sorry, not 2, 1. Then you have short int, which takes 2, int, which also takes 2, long int, which takes 4. Now, assuming it is 16-bit, remember, this is assuming it is 16-bit. If it is 8 bytes, it is 32-bit. You guys know this. Again, int also for 16, it is this, and 4 if it's a 32-byte system. Then you have float, which takes 4 bytes, then double, which takes 8 bytes. Now, how about long? How many bytes will this take? Any guesses, guys? Just also remember, by the time you let me know how much size long takes, long float is also same as double, which also takes 8 bytes. So back to this. Any guesses on long, guys? How much size would it possibly take? I have one answer. How about others? Anybody? Alright, so it does take exactly 8 bytes. That is perfect. So you have size taken by variables is equal to this. Now, assume to calculate space complexity, you have something like, let's say, a block. Let us take this block of code, and I'll just write here something like int, let's say, a equals b plus c plus d plus e. Assuming all of these are int, and you take up and you observe this, your entire time complexity is calculated by looking at how much bytes do all of them take. So we know that total requirement, assuming all of these are integer types, are 5 of these variables. Each one of them take 2 bytes, assuming it's 16-bit compiler as well. So you will have 5 into 2. That will be entirely 10. So you can say 10 bytes is the space complexity. Since space complexity is fixed, so you can call this as constant space complexity. Whenever you have dynamic memory allocation or any such things, it's not a constant space complexity, it's a variable value. Now, let me ask you guys one more question. If I take a function, let's say void fun of int a, int b, int c, int d, and int e, and let's assume all I'm doing here is calculating int z equals a plus b plus c plus d plus e, and let's say I'm just printing percentage d comma z. Now, what will be the space complexity for this? Pretty easy, guys. Give this a try. Now, this is not difficult. This is an easy question. You have 5 variables plus one more variable. Total, you have 6 variables declared. So 6 multiplied by 2 will give you 12 bytes. Absolutely correct. Now, if I take the same function and instead of void, I'll make it int, and instead of printf, I will return z. How about now? Will it still be same or will it be different now? Think through, guys. Think through and let me know. You can take a minute of time if required. Just think through and you can let me know. So remember, for those who are saying same, whenever you use return, it does take 2 extra bytes, because whatever value is to be returned back to the function, since you're returning it here, it must be stored somewhere outside. So for it to be stored somewhere outside, it takes 2 extra bytes. So you can say this pretty much is where you have 7 into 2, that is 14 bytes. You can in short say that whatever is returned takes 2 bytes to store in memory. So like this, you can expect maybe a small question, because I haven't seen too many questions of space complexities, very less. So I will also not take a lot of questions. I'll also take very less amount of questions only. So now in the next case, let us say we are sending an array. Let's call int star array and int n. N is the number of elements for the array. All that we are doing here is taking something like int sum is equal to 0. Okay, since we have sum here already in the function name, not to confuse you, I will just take int sum underscore array is equal to 0, and let's say we'll just take something like for int I is 0. We know initialization executes once, only once. So if you guys can go through this, can you think through what could be the space complexity here? Now remember, previous was a constant space complexity because it was a constant number. That is why we called it as a constant space complexity. Here, that is the clue for you. Here you can figure out, think through and let me know what could be the space complexity here by going through your previous example. So I've got one answer, that is 4 plus n. So let's see if anybody else are able to answer it. I'll wait for a minute. I need as many of you guys to respond as possible. So give it a try, guys. I've got one answer as 4 plus n. What about others? I've got one answer as 4 plus n. Let's see if anybody else is answering anything to counter this. Right, I have one more thing called output as 10 and another one as 2n plus 6 and one more as n plus 6. So these are the answers we've got. So now that we've seen these answers, let me solve the same. Let's solve the same and exactly see what could be the output required. So it is not exactly 4 plus n that I'm going to take. If you observe this, think about it. This sum underscore array will take exactly 2 bytes. They know this. Then here, to begin this, you know that you're sending one more integer variable here as well. So n is a variable which takes 2 bytes. Let me write it as n takes 2 bytes because n is of course a variable, and this is not just a pointer we are talking about. Remember, along with this pointer, you are storing entire array. You are storing entire array ARR. So the entire array will have n elements. So since each element takes 2 bytes, entire array pretty much takes 2n. So you can say here as 2n is for, sorry, array will take exactly 2n bytes. I hope this is the first point that is very clear as to why array will take 2 multiplied by n amount of bytes. And after this, only one of you answered it as 2n plus 6, which is correct. So we have got one more variable called sum underscore array, which takes 2 bytes again. Along with this, you've got one more variable that is you're returning some out of array to somewhere else where you have to store it. So you're returning some array to store somewhere else. So for return statement, since it has to be stored in memory, while returning, it will be stored in memory without a doubt. So that is why that also takes 2 bytes. So your entire output here will be 2n plus 6 bytes. Now here, this depends on n value. It depends on a variable value. So as n increases, this value also increases. So we call this as not a constant space complexity, but a linear or a linear growth space complexity. So just a basic terminology and concept you all need to know when it comes down to this. So this is how you can start figuring it out as to how will or what will be the time complexity or sorry space complexity required. So always remember, you have to keep observing what exactly will be so I have one question. Yes, oh sorry, yes, see, apart from return, of course there is one as well. So you have I as a variable which also takes 2 bytes, right? So essentially it comes up to be 2n plus 8 in total. So this is your space, linear space complexity. I totally forgot about I, yes. So this is your space complexity over here. So I have one question. Size of array will not return to n. See, the reason size of, okay, to answer this question, observe this. See, uh, in this case, we know that n takes 2 bytes, I takes 2 bytes, sum of array takes 2 bytes, and returning it and storing it to some other array place also takes 2 bytes. Then we know that this is a pointer. And I understand that when you provide size of the array name, since it's a pointer, it will only show 2 bytes. So does that mean the whole array is taking only 2 bytes? Because see, whenever you're calculating space complexity, you need to figure out if you're getting data from somewhere else. You have to figure out how much of data are there, how much of data is exactly there. You're having a pointer to an address by default, it always points to starting address. So here you have some values like 10, 20, 30, 40, and 50. So we know we can't store all of this in the size of a pointer, which could be 2, 4, anything. So all of these will require their own, let's say, 10 bytes of space. So if there are n elements, they require 2n elements, 2n bytes of space. So this is why we specified as 2n. When you print size of ARR, it is printing size of this pointer, not the size of entire array. So I hope that answers the question. I hope you were able to understand with that as to why size of ARR does not provide. Okay, complete, perfect. So yes, there is iterator variable int I is also there, based on which we are taking 2 extra bytes. Now, going ahead from this, you can have space complexities which can be quadratic as well. Whenever you have n square in it, it becomes quadratic, and so on. There are lots of exponential space complexity. There's a lot of things, but space complexity is not the kind of question we need to worry most about. We need to worry and learn more about time complexity. So this is where I will pause the concept of space complexity between us, and we'll directly go ahead for time complexity instead. Now, to understand time complexity, you need to know that we calculate it only using number of operations, never using time taken. Now, think about an array. First, let us try taking a simple example of an array to calculate how exactly number of operations work like. Then we will go for the definition and some interview case examples. So let's say you have certain values, so 10, 20, 30, 40, and 50. Now, whenever I try to access this, let's say whenever I try to access an array, if it is to access elements, or if it is to, let's say, read elements, if I want to read an element, whether it is index 0, 1, 2, 3, 4, how many operations should I do to read an element of an array? Should I do just one operation or two operations? Or if I want to read nth element, should I do n operations? See, guys, remember the basic formula. If I want to read a of 4, all I will write is just a of 4. What will the compiler do? It's going to convert it into star of a plus 4 and directly access this address. Are we going through a of 0 and then uh, going to a of 1, then a of 2, then a of 3, then a of 4? We are not doing that. We are directly able to access a of 4. So can I say number of operations done is just 1? Worst case in number of operations to access any a of n value is just going to be 1, because it does not require too much time to access any variable value like that. So here you can say worst case or worst complexity will be big O of 1 for reading, because whether you want to access first index, second index, third index, fourth index, any index, you're just accessing it by one operation, a of I, that is all. This will give you index i's value. Is this clear as to why reading only takes 1? I'm talking about worst case where reading only takes 1. Let me know, guys, are you able to understand this basic concept? Since we are starting with the basic concept of time complexity, I want to ask you guys whether you're able to understand it possibly, or does it feel difficult to understand, because these are basic things. So if you have any questions, any doubts within this, you can let me know. So going ahead with this, the next thing, after reading, let's go for the next value. If I want to search for an element, let's assume we want to search for an element. In that case, what could be the worst time complexity. Can you guys figure out and let me know? Is it big O of n, or is the worst case big O of n plus 1? Think through, guys, and let me know. Observe between the two values I've shared and figure out and let me know whether it is big O of n or big O of n plus 1. I've got one answer. What about the others, guys? What about anybody else? All right. So just remember this, whether it is, whether, see, what is the worst case scenario? There is no element. You're searching for an element that is not there. So think about that. So you're searching for an element, let's say 60, which is not there in your entire array. So if you're searching for an element which is not there, first you're going to search in index 0, it's not there. Then index 1, it is not there. Then index 2, it's not there. Then 3, not there. Then 4, not there. You're not going to go to 5 after this. So if there are 5 elements in total, you're performing 5 comparisons only. If it's not there in any of those 5 indices, you're saying not found. So this for search is exactly big O of n. Its complexity will exactly be n because you are performing exactly n searches. Similarly, we'll go for two more things before we go for a little bit of theory about this. If you go for insert or if you go for delete, how about now? See, if I go for insert, if I want to insert an element at the beginning, that means I have to shift my first value to second, second to third, third to fourth, fourth to fifth. So total 1, 2, 3, 4, and fifth to sixth. 5. 5 operations is what I have to do. After performing 5 operations, I have to insert here, which is one extra operation. So there are totally n plus 1 operations. But we are talking about worst case scenario. In worst case scenario, we assume n is a large value. N is a very huge value. So when n is large, does 1 even matter to be next to it? It does not. So instead of writing big O of n plus 1, we will just write it as big O of n in short. So even for inserting an element, this is your time complexity, and even for deleting an element, your time complexity will be pretty much the same. So here, if it's for deleting an element, again, assuming the exact same case, if you're deleting this, you have to, first operation is to delete this, then to switch 20 here, then 30 here, then 40 here, then 50 here. So exactly 4 plus 1, 5 operations only. So it again purely depends on n. So you can just write it as big O of n. So worst time complexities for all of these except for reading will be big O of n. So you can understand that here we should use the data structure that is called an array whenever you're reading elements. Whenever you're writing into data structures often, then time taken is more. Time taken is much more whenever you're writing into data structure of array. So that is when you use a different data structure. So this helps you understand that we use arrays only while reading values a lot. Wherever you want to use data structure of arrays, remember insertion and deletion should be less and reading of values will be more. On the opposite way, if you want to insert and delete values a lot, we will use something else called linked list. We will look at linked list later on. But first, let us get back to a little basic concept of time complexity and learn how to figure it out, how to calculate it, how to solve these things and everything. So time complexity, as we talked, is pretty much calculated by number of operations you do. Now, take this simple thing for example. if you have. So can you let me know what will be the time complexity here for this code? For this one for loop, can you guys observe and let me know what will be the worst case time complexity? Of course, there's worst case, average case, best case is all going to be the same in this case. There is no difference because it purely depends on one value, that is n. So its worst case time complexity will be big O of n because n times the statements are executed or n times the operations are performed. So essentially, easily you can say it is big O of n. You can say this is linear. For every increment in for every increment in n, number of operations linearly will increase. Now, instead of this, if I take, let's say, something like this, how about this one, guys? Again, this is also simple, easy question. Uh, Give this a try. Give this a try and let me know, guys. Think through. Perfect. So let's say if n is 2, that means for first value you have to access this 2 times. For the second value also you have to access this 2 times. So essentially you're getting 4. If n is 3, you're going to execute this loop 3 times, and each time you're executing it, you're executing this 3 times. So 3 into 3. So in other words, you can say big O of n power 2 or n square. So you can say this is not linear but quadratic. Now, if you have just one statement like int sum equals 10, this is your linear value. So you can call this as big O of just 1. So you can call this as constant, not linear. You can call this as constant. So there are all these different ways. But what I want to take up for an example to understand the difference between these for us is I'll take binary search. See, you guys know that this is for linear search. Linear search, this is how it comes up. So I want to take an example of binary search and I want to ask you guys what will happen here. So assume your basic binary search algorithm. I'll only write the major points within it. Like if key less than, let's say, array of mid, what we do is generally do something like high equals, let's say, mid minus 1, else low equals. Alright guys, observe this now. If you look at this, can you figure out time complexity of this easily? If so, what will be the time complexity? Any guesses, guys? Any answers? Think through and let me know. Any answers? Is it big of n or is it big of n square? Which value will it be? N or n square? You guys can let me know. I've got one or two answers. Any else? If you calculate this, if you perform this, it is big of log n. Now, how exactly do we figure out what is log n? This is the big question that comes to our mind, because we can easily calculate how um, its value will be in various cases. But what is log n? See, log n, I'll just say in a very short way what log n does. This is smaller than n, and this is bigger than big O of 1. This is how it works. So to understand this basically, you have to remember what is log 2. We generally calculate these based on log 2. To perform the to figure out what is the answer, you guys need to figure out what is log 2. So I hope you guys are familiar with logarithm calculations. I'm just going to take you back a little bit to mathematics. Don't worry, we won't go into deep mathematics a lot. If it is log base 2 of 16, what will be the value? Or if it is log base 2 of, let's say, 32. If you guys don't know this, just remember 2 to the power of n should be 16. And that n, whatever you want to type, you are writing here. So 2 to the power of 4 will be 16. And 2 to the power of 5 will be 32. So this is basically how you calculate log base 2. Now, what exactly we are doing here is, on an average, if you're calculating for log, for 16 elements, you're taking 4 steps on an average. On an average, for 32 elements, you're taking 5 steps. This is on an average what we are going to say. For these many elements, you're taking these many steps. So that is exponent of 2. So let us see, is this correct in our case to understand with a binary search. So we'll just take an array to understand this. Again, always you need to initially start learning calculating time complexity by writing arrays down and everything, so that later on calculation of time complexity becomes very easy for you. So I'll just take this as, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll also call it as 10. Now, assume that you're uh, finding out some value. Let's take that value to be 0. If you're finding out 0 using binary search, here's the first thing you're going to do. You have index 0, 1, 2, 3, 4, 5. All right, till here. So first thing you're going to do is take this number of values 10 by 2. Whatever value you get, that is 5. So that is the index you will go to. So we'll go to index 5. This is our first comparison. Now, it is not equal to or greater than. So let us go below it. Now, below it I have 0 to 5. Sorry, 0 to 4. Let us take again this index by 2. I'm getting 2. So I'm getting somewhere around, this is my second step. In my second step, again, all of these are skipped. Then again, 0 plus 1 by 2, it is 0. This is my third step. I'm comparing here, it's not found. So this is where I'm stopping. So essentially, for around 10 elements, I'm going through somewhere around 3 steps. So like this, if you figure out and calculate, it will come up to something like log base 2 of n nearly. So for 16 elements, you take somewhere around 4 steps, somewhere around 4 steps. It could be slightly plus 1 or it could be slightly minus 1. But since somewhere around close to it, technically we call it as big O of log n. Now, for us to work with interviews, there is an easy way to remember these things. There's an easy way to calculate all of these. So you have log n, then how do you figure out where you need to use n log n? because for something like let's say quicksort, since you guys said that you don't know a lot of sorting algorithms yet, I will not explain this now. I will explain this when we go for quicksort. But just remember that quicksort has big O of n log n as the worst case time complexity. So to figure out how we calculate it and so on, let us take one example. I'm going to give you guys this basic example to understand. Say, first, think about this. If you are dividing the data, let's say you have some amount of data. Let's say you have n elements. If you go through each element one at a time, it will linearly increase by increasing n. So this is where you've got big O of n. If you're going through two-dimensional arrays, that is pretty much for each n value, you're going through n columns. Then again, for second row, you're going through n columns. So this is where you pretty much call it as big O of n square. But if you have an array where you are dividing it into half, pretty much what you call is a divide and conquer technique. Uh, all of these techniques and everything we will learn when we go for algorithm part. We are still in data structures. We'll learn when we go for algorithm part. So if you use mostly any divide and conquer method, if you're dividing by half and considering only that half, rejecting the other half, it is lesser than going through n elements. That is same as big O of log n. This is just one basic example you may need to know. So these are how you can calculate big O of 1, big O of n, log n and everything. So let us go through a few examples to calculate time complexity. Let's say I'll give you guys a program like so what will be the time complexity here, guys? Just look at this program. Very easy and simple. This is not difficult at all to start with. It's big O of just one because it's a constant, only one printf, one statement. That is all there is. Now, if we take the exact same and let's say I paste it here, but instead of this, I will take something like int I comma let's say n equals 15, and I'll take something like how about now? What about in this case? This is the operation you're performing. This purely depends on, I've just given it as 15. If I had given this as I less than equal to 15 in your interview, time complexity is 15 exactly, 15 operations only. Always it will be a constant. It will be big O of 15. Now, if I replace this program, instead of I less than equal to 15, if I give it something like I less than equal to n, and let's say user enters the value of n, then in this case, you have to specify time complexity to be big O of n. Because in previous case, I made it I less than equal to 15, not I less than equal to n. When you make it I less than equal to n, know that n is the variable which you are using here. So this printf statement is executed n times, which can change based on n value. So give it as big O of n. But here, since it is not changing, it is always executing 15, no matter what value you give to n. Since I've given I less than equal to 15, you will get 15 only over here. So that is the difference over here. So like this, you guys can expect a few questions. So let me take up a couple of pseudo codes now. Let me take a few pseudo codes, and I will ask you guys to figure out what will be the time complexity of all of these. So let's say I'll take a pseudo code of function of a comma b. Here you're performing a return of a plus b. So again, a simple one. How about now? Very simple one. So perfect big O of 1. So going ahead with this, now that you guys know what will be the exact time complexity of this, let us take a few more and more slightly complicated problems, because I want to take, see, time complexity is something I may expect. We may expect such questions for sure. Now, let us take as much as possible, as much questions as possible. Let's say we have a defined something like um, constant of n, and I'll just call it as, or define, well, let me just type it in short as function of n, and here we'll just write alright guys, how about this one? We've gone through such a problem earlier, we've gone through such a problem before. Think through and let me know guys what could happen here. Perfect. So how about anybody else? I've got one answer. Anyone else? I need a few more to figure out what will be the answer for this, not just one person. So take half a minute if required. Think through this. Think through this and let me know, guys. All right. To understand this, let me ask you guys. In this case, if I have 2 power n elements, is n my number of steps? Approximately, for 2 power n elements, is n my number of steps? If so, then it is big O of log n. For those who are saying n square, it does not execute n square times. Now take this case. Let's say n is 10. Let us assume instead of 10, let's say n is 16 exactly. Now, when n value is 16, we check it while n greater than equals 1, true, n by equals 2. So first time while loop executes, while loop is executing first time, n becomes 8, and it will increase result equals result plus 1. I'll call it as result equals 1. Then second time while loop executes, again, we are checking 8 greater than equal to 1, true. So it's going to get divided by 4, 2. So n becomes 4. In the third step, n becomes 2. In the fourth step, n becomes 1. So that is when we stop. So essentially 4 steps. Isn't it 2 to the power of 4? 16. So you can figure out it is log n. You can figure it out that it is big O of log n when you have 2 power n as inputs and you have to execute the step exactly n times. You have to perform the operation n times. This is how you can find out it is big O of log n. So your output here is exactly big O of log n. So this is the first thing you guys need to remember. Is this clear, guys? Do you want me to go through this again, or I hope you're able to understand this perfectly. I hope there's no doubts about it. Let me know, guys, because a lot of you said things apart from big O of log n. So I hope for all of you this is very clear. For everyone who said it is not log n, I hope it is very clear. Now I'll take one more case. Function of, let's again take input as n. Now for we'll take I equals 0 to n minus 1. If let's say we'll give one more input value, let's call it as x, and an array a, let's give 3 values. So let's say if array of I is equal to x, return let's say 1, and I'll say return 0 at the end. Now what about the term complexity here? I don't think I even need to explain this. This one is too easy. I don't think I even need to explain this part. Perfect. Big O of n. I hope that is clear. I don't think I need to explain this part at all, because at maximum, if x is not present in the array, it will repeat this for loop for all the values if x is not present in the array. We are looking at the worst case. We are looking at the worst time complexity. That is why we will say that if x is not found, worst complexity, you will repeat this n times exactly. So let's continue ahead. Let us go to the next step here. If it is function of, let's say something like it's a double two-dimensional or two-dimensional arrays, let's say. I will tell you when you should take big O of 1 for comparison. Yes, that's a really good question. You need to take big O of n for comparison in certain cases. I'll tell you where exactly you should take that and where you should not. Now, observe this. I have a question. Do we consider big O of 1 for comparison? To understand that, let me go for this particular case. So what will be the time complexity here? Again, this is also an easy question. We have already performed all of these. These should not be difficult for you. And of course, we go n squared. Now, I have a question here. When should time complexity be considered for big O of 1, and when should it not be considered? That's an important, interesting question. If you observe this code, you know that whatever, if you observe this particular code, you know that Here, whatever I have selected here, only this small for loop part. This is for big O of n square. Apart from this, you have here result equals 0 will take exactly one step, one operation. So you can call this as big O of 1. Then returning result is also one step, one operation. You can call this as big O of 1. Now, can I write this as big O of n square plus 1, or can I write this as big O of n square plus 2? For a huge value like n square, does 2 even matter? Does 2 even make a sense? It does not. So we directly call it as, no need to write 2 as a separate part. We'll just call it as big O of n square by generalizing it. This is what we call it. We will approximate big O of n square plus 2 to, will approximate it to big O of n square. This is what we essentially do to figure it out. So I hope this answers the question as to when not to consider big O of 1. So, all right, perfect. So let's get back here. And again, let us look at some other kinds of questions that you may not expect to have studied elsewhere, but you may expect in interviews. Again, I'll go for function of let's say n comma m, and I'll again take something like result equals 0, and let's say for how about here, guys? What do you think could possibly be the time complexity for this function? Take a minute, think through if you want, and let me know. After this, we'll go for some exponential time complexity examples, some more exponential examples. So I've got one answer. Any others? See, the first statement you can call it as 1. Second statement you call it as n. Third statement for loop you call it as m. Fourth statement you call it as 1. So you can call it as big O of 1 plus n plus m plus 1. So plus 1 and plus 1 are very small. I don't need to consider it together. So instead I'll just take it as big O of n plus m in short. So here you can expect it as big O of n plus m. This is also linear. It's not necessary that you always have to get the same kind. Now, since you have understood this, I want us to go back to a previous example because of this case. Let us go back to one of the previous examples where we have calculated a sum of elements, if I'm not wrong. If we haven't, let me write this quickly just to calculate this, because this will help us figure out how to calculate time complexity when you divide it step by step. Let's say you have sum of array comma n. In this case, what you're performing is something like initially sum of array is equal to 0, and for I equals 0, let's say 2 n minus 1. We're just calculating sum array plus equals array of I, let's say for example, and we're just returning sum. no need of semicolons, it's just a pseudocode. Now, if you observe this particular pseudocode, here, the first statement takes one time. Cost is 1 because it executes one time. This particular loop here takes exactly up to n times. And this step here takes one time. Now, if you calculate this, it essentially becomes something like, see guys, one more thing, if you calculate this, you essentially get something like n plus 2. Now, plus 2 does not matter much, so you essentially make it as n. But there is one more thing to observe here. There are two operations being performed in this for loop. One operation is increasing I value, another operation is calculating sum. So here, if you're saying this is performed n times, the number of operations done here are 2 into n. Technically, if you calculate it, number of operations done are 2 into n followed by 1. So now if you calculate it, you're going to get big O of 1 plus 2n plus 1. Now again, we'll just call it as big O of 2n for now. One more thing you need to know is, whenever we calculate this, you can say that this is same as big O of 2n plus 2 can be same as constant 1 into n plus a constant 2, and these constants are generally considered too small and not taken, so you essentially end up with big O of n, because we assume this for the worst case scenario of the largest numbers. So a smaller constant, we say that it does not matter and we'll just call it as big O of n. So this is an approximation that generally happens, which you guys need to know. So now that we saw some basic examples, some very basic examples uh, of time complexities, we will now go to our basic data structures and figure out, uh, yes, in that case, see, technically in that for loop, it can be considered in both ways. There is one operation, or if you want to go technically within this, you can say that it is entirely two operations. But generally what we do is, for an entire loop, we call it as one operation. Whatever the amount of steps you have, sometimes, generally we call it as, for an entire loop, one operation. So to understand this better, if you look at binary search, in binary search, when we divide the array by half, take example, when we divide the array by half in binary search, exactly, you know that to divide, you have an else statement, and if statement, another else statement, conditions. So you can say there are 3-4 conditions, so I'm going to take it as 2 times the same thing. But we generally assume as, for a whole loop, we call it as n times, immaterial of the number of statements it executes, unless that is hugely impacting. So that is what we generally say. So getting back to this, let us start with stacks and queues and figure out their time complexity, figure out how they work and everything. Now, let me ask you guys, do you guys know the basic working of stacks and queues? Do you guys know the code of it? Are you guys able to, if I ask you to, will you be able to create, let's say, push function or pop function or enqueue function or dequeue function instantly? Within a few minutes, will you guys be able to create them easily? This is my question for you guys, because that is very important for some interview questions. I will explain, I will give you an example as to why it is important. So are you guys able to create these easily for stacks and queues? This is my first question before I go ahead. You guys let me know with yes, we are able to, or no, we are unable to, whatever it is, according to you. All right. So before we go ahead, with this concept then, since you guys are able to do this. Before we go for the direct time complexity calculation, I wanted to ask you guys, particularly because I want to know which examples should we take and which examples should I not take in terms of coding. Uh, if given a question, something like, uh, let's say, infix or postfix evaluation, will you guys be able to understand the code of it? Or given a linked list reversal, or let's say a linked list search element code, will you guys be able to go through understanding that code instantly? Or if it's something like binary search tree, traversal, or search element, if they provide you with the code, will you be able to analyze and understand it immediately? Because if they ask you these questions and they say there is an error in some line, we need you to figure out which line the error is in, will you guys be able to remember and compare the code that is correct in your mind to whatever they have given instantly? Or do you find these as difficult? Because if you find these particularly as difficult, I will go through them in our sessions. So this is what I want to ask. For all three, whichever you find it difficult, you can let me know right now, so that I will take up content on the same with diagrams and everything by the next session. Or if you guys feel all three are difficult to start with, you can let me know. We'll go through some coding of all three to make it easy. Or if you feel all three are easy also, you can let me know. All right. You guys want me to go through all three of these? All right, not a problem. We'll do that. But you guys are clear with all of these, right? Basic push pop NQ DQ function. I hope you're all clear with, because you will expect a question like this. Since I don't want to type the entire code, which will take a long time, let me just go online and just search for um, a stacks C language code for you, so that you can get this. So I'll just take some random code, whichever it is supposed to be. So here, uh, assume that this is the case. Again, sorry, this is based on stacks. I want to do it based on arrays right now, because we are starting with the concept of arrays. So let's say this is your simple push function. So assume they're giving you this particular question in interview, and they will ask you, point out which line has an error. And since we know that top should be pre-incremented before inserting, what if I make it as, instead of pre-incrementing, I'll make it post-incrementing here. And now here is where you guys should be able to know where exactly your where exactly this program is wrong. So unless you know basic concept of stacks, you will not know which line the error is in. So they will give you a few line numbers, and they will ask you which line the error is actually in. So this is one thing you guys would need to know and need to try to do. So this is something you guys can do easily, right? I hope. Let me know, guys. Guys, just let me know. Will you guys be able to do these sort of calculations easily by yourself? If so, then I will not go through stacks queues in detail at all. I will not go through them at all. I will only go through linked lists, directly through linked list. So just to know, just to specify, you will expect these sort of questions where you will get a function and they will ask you a question like if you're able to access or if there are any error in which line the error is and something like that. So these are some kind of questions you may expect. Or instead of point to which line has an error, they can also replace that question as given there's an error in line 2, what will you replace it with? And they will give you 4 options of any 4 statements. And unless you know this code, you won't be able to replace it. That is the other thing you need to know. So let me ask you guys back to one question back here. When it comes to stacks, when it particularly comes to stacks, what is the time complexity that you guys will have? My first question. Now, you know, stacks have 4 particular functions. One is push, another is pop, another one you're checking if it is full, another one if it is empty. So in short, how many, let's say in this case, what will be the time complexity for push? Can you guys let me know? Just think through. Assume you have an entire stack here where you can store 5 elements. What will be time complexity for push? Think through, guys. I'll give you guys just a minute of time. Take through and let me know. Guys, think through. It is not difficult. It is really not difficult. I've got 2 answers. What about others? Any guesses, guys? Think through. All right. Observe this, guys. In this case, if I want to insert one element at the bottom of the stack, see, assume stack is empty. If I want to push an element, I can directly push it here. Assuming it has one element, I can directly push the next element here. Assuming it has 2 elements, I can push the third element directly. Now I can do this because we have a variable called top. Remember, we have a variable called top in stack. When the stack is empty, we know top is -1. So when all we need to do whenever we call push is just check what is value of top. Let's also remember stack has one more variable called size. Size will always be the how do I say, number of elements you can store in this. Now, since you can store up to 5 elements, first thing, when stack is empty, we know top is equal to -1. So I can just perform push. It will increase top to 0, and then I will store the value here. When I perform push again, it will increase top to 1. I can store a value here. When I perform push again, First step, increase stock, store value. Then again, fourth step, increase stock, store value. Then again, fifth step, increase stock, store value. Then again, last step, check it is equal to size minus 1. Don't increase, just stop right there. So can I say it is a constant amount of step? It is something like just one step that I have to take. So can I just say that it takes big O of 1? Because to insert an element, I do not have to repeat n times. So can I say it is big O of 1? Because some of you said that it is big O of n. This is why I'm asking. Can you guys let me know why it is big O of 1? So particularly for those guys who said it is big O of n, are you guys able to understand why it is big O of 1? Yes, perfect. So now that you guys are able to understand this, can you similarly figure out what will be the case for pop? If it's big of 1 for push, what will be the case for pop? Assume you have 5 elements. Now that you know how much time push takes, finding out how much time pop takes should not be difficult at all. Let me know, guys. As many of you guys can try think through and let me know. So we've got different answers particularly, but yeah, most of you are able to easily say that it's a constant which is supposed to be 1. So essentially pop is also big of 1. Easeful also you're just checking one condition. If top is equal to size minus 1, that is also bigger of 1 essentially. And is empty also it is bigger of 1. Essentially you can say no matter what you do, it's always bigger of 1. Now this is what we have searched here. For push pop is full is empty, it is bigger of 1. Now on the other hand, if you're searching for an element, if you're searching for an element or if you're deleting an element, in that case it will be big of what? Think about these. You have understood the constant value very clearly. Now that we have taken several examples, we have taken many examples of time complexities. What will happen for search and delete? Can you guys think through and let me know now? A clue, both are same. So yes, perfect. It is big O of n exactly. So going ahead from this, now that we know very much how your basic operations in a stack will take. Push operation will take big of 1, pop operation will take big of 1, search will take big of n, where n is the number of elements in your stack. Also, delete function will also take big of n, where again n is the number of elements in stack. Knowing all of this, let us now go for a queue. In a queue, you know that you have something called a front variable, you know something called a rear variable. Again, remember, you guys will expect questions like a code will be given. Code will be given where some line there will be an error. Instead of front plus plus, they may do something like plus plus front. Instead of rear plus plus, they may do something like plus plus rear or minus minus rear or something like that. So you have to figure out which line has the error. They will give you line numbers appropriately and everything. So these are some sort of questions you guys can expect. But since all of you have said, sir, for stacks and queues, we are good with the code. We don't need to go through this. So that's why I'm not going through them. So instead, I'll directly go through, let's say, time complexity of them. Now, again, one basic simple question to NQ. To NQ as in insert within a queue, or to DQ as to remove an element from a queue. What will be the time complexity? Think about this. To NQ and DQ, what will be time complexities? Then we will search. Then we will find out time complexity, particularly for search later on, and for delete as well. My first question to you guys is, think through, guys. This should not be difficult for you. We have solved so many of these things. This should not be difficult at all. Okay, just think about NQ and DQ. I'm not asking search and delete. Think only about NQ and DQ. You guys know basic functionality of a queue, right? You insert elements from the rear, you delete elements from the front. This is how it basically works. Initially, by default, front and rear will both point to first element when there are only one element. So when there are two elements, rear will point to second value. When there are three elements, rear will point to third value, and so on. This is how it goes. You guys know this. So this is front of the queue, and this is rear of the queue. Now, what will be the time complexity for NQ and DQ? Simple, easy question, guys. Do let me know. So pretty much one absolutely correct. So it's big of one. Now, what about search and delete? NQ and DQ, it's big of one. I don't think I should explain this further on. It's easy for you guys. What about search and delete? Just remember, from front till you reach rear, if there are n elements for searching, you're gonna need, of course, n searches minimum. To delete, if you're deleting something, you have to switch all the others. If you're doing that, you need n, but if you're not doing that, you need only one, especially in a circular queue. Remember this, guys. This is the difference. In just a regular queue, let's say I have 1, 2, 3, and 4, and 5. If I'm deleting the first element in the queue, second element must go here, third element must go here, fourth element must go here, fifth element must go here. Then you can say for a queue to work well, delete should take n elements and as time complexity. But instead of this, if let's say for example, it is something like let's say it is something like this instead. Now here, in a circular queue, assume you have a circular queue. You know that in a circular queue, if you're storing 1, 2, 3, 4, I have a question. Explain linear and circular queue. Okay. Um, I'll ask you guys. Do you guys want me to explain the difference between a simple queue and a circular queue? How a simple queue works or how a circular queue works? Okay. What about others? You guys let me know. I need majority of responses to go through these. So as many of you guys can let me know, it'll be easy for me. So depending on majority of responses, I will either go through it and try explaining it in detail, or depending on majority of responses, I will just say like, in short, this is how it works. So most of you require it. All right. So um, let me not go through circular queue to begin with. Let's go through a simple queue. Now, this is where I'll tell you guys, if you find queue concept difficult to begin with, when they give you point out an error function or point out an error program, you will find those difficult as well. Like, let's say I'm just going for stack. Let me just open up queue here. I'm hoping they have their code. No, they haven't. But let's take it something like this. So they may even give it by pseudocode. There's a good chance they may give it by pseudocode. Pseudocode is just algorithm. You guys know that. So let's say this is your pseudocode. Now in this, instead of front equals front plus one here, they will just make front equals front one plus one here. Now, if you look at this code and you don't know how dequeue function works, then this entire program will be difficult for you. So what you need to pretty much know is how to how dequeue actually performs. What happens in a dequeue function? If you don't know that, then you won't be able to find out the error in this code. So remember such questions when they're asked, you need to know these programs. Unless you know these programs in detail, it will be difficult for you to solve them. So I think I've taken too many elements. Let me just take 5 elements, which is easy to begin with. Let's take, you have index 0, 1, 2, 3, and 4. So you have 5 elements in total. So let me just explain how queues work in short. By default, queues need two variables. Stack only needs one variable called top, which indicates the topmost element in the stack. But in queue, you need to indicate which is the first element in the queue and which is the last element in the queue. Because in a top, you only entered values. In the stack, you only entered values from one end, you deleted values from the same end. But here, in queues, you enter values from one end, but you delete values from the other end. So you need two variables to mark both places. So that is why we're going to use a variable called front and rear. Both will be -1 by default. Now, here's what happens initially. So when you enter a value, let's say when you enter your first value, let's say 10, this is in the first element of the queue. Front will also point here, rear will also point here itself. Now, if I enter second value, front will remain the same, but rear will point here. If I enter third value, front will remain the same, again rear will point over here. So whenever you keep on inserting elements, rear will keep on increasing until rear points to the last element over here. Once rear points to last element, I cannot insert any more elements. This is my condition where is full occurs. So when I want to delete an element like 10, I either need to delete this and move 20 here, 30 here, 40 here, and 50 here. Or basic definition of queue says, when you delete it, front will be pointing here. And when you delete this also, front will be pointing here. Now, the problem is, I've deleted the first two elements, but I still have two spaces free. These two spaces are free, but I cannot enter anything in these two spaces because I can only enter elements at the rear end of the queue. I cannot enter elements at the start end of the queue. From the front end, I can only remove elements. From the rear end, I can only enter elements. So I will not be able to enter elements here. Given, even though there are two spaces free, I won't be able to enter elements as long as all these elements are deleted and front becomes -1 again and rear becomes -1 again. Until that happens, I cannot enter more elements. That is the one problem that you have in simple queue. Is this clear, guys? Is this basic concept of queue clear? If it is clear, I hope you will be able to also go through the questions that I expected, like if it is like this, how to solve these. Now, the next thing you guys want me to go through is a circular queue. Let us go through the same. Let's take something like this. All right. So now again assume there are 5 elements: index 0, index 1, index 2, index 3, and index 4. Now in this case, it is circular in nature. So after index 4, it will go back to index 0. The way we go back to index 0 is by performing modulus with size. Whatever value it is, if we perform modulus, after going 4 plus 1 is 5. 5 modulus size, which is 5, will come back to 0. It will not exit the queue. So this is the basic concept of how we do it. So I hope you guys are familiar with the code again, because if there are questions asked like point out the error in this code, you should be able to. Now, anyway, let's get back to this. In here, let's say I'm entering one value. So this is my front and this is my rear. So if I enter one more value, my rear value will increase to here and so on. So let's say we fill our entire queue, 30 here, 40 here, and 50 here. Now, once I fill the entire queue, if I delete 10, 20 will be my front. Again, if I delete 20, 30 will be my front. So this is our front value. This is our rear value. Now the condition here is, in a circular queue, you can increase the rear value even to 0, it can be done. So if I enter one more element, it will increase rear value and enter it here. So this will be my rear value. If I enter one more element, it's going to increase rear value and enter here. This will be my rear. Now, if I enter one more element, it says, hey, you can't enter any other element, because after rear, front starts. This is where the queue starts. This is where the queue starts. And after going through the entire queue, this is where it ends. So there is no space between end and start. There is no more element space here. So that is why you can say this is where queue is full. When front is equal to rear plus 1 mod size or something like that. Let's not go into that in deep for now. But this is where you can say queue is full. Circular queue is full. So this is your basic concept of circular queue, where just because you deleted, let's say, some values from the front of the queue, it does not mean rear of the queue cannot go back to the start. It can go to index 0, 1 as well. As long as it does not reach the same index as front, it works perfectly. This is the basic idea. Are you guys clear with this? All right, clear, perfect. So this is where you guys can get to know questions like, in this case, you can even get a question like, for insert, what will be the big O, what will be your time complexity? Insert is just 1, delete is also 1. For search, it is n, and for these purposes, you guys can figure it out. See, for insert and delete, it's always 1, because insertion is done with front, sorry, insertion is done with rear, where rare will just go by one and insert it here. That's all. Deletion is done just by pointing front to a separate value. So that takes only one step. Whereas search will take a lot of steps. If there are n elements, you may have to search for all n elements in the worst case scenario. So search is where you can go for big O of n. So this is how you get to find time complexity of these very basic um, data structures. Now, going ahead from here, let me get back to a small question to you guys. So back in this case, if this is my front value, if this is my rear value, can I just say if front double equal to rear plus 1, can I just say that it is can I just state this? Does this make sense? Is this absolutely correct logic? If it's not correct, guys, let me know what should be changed. Okay, those who are saying it is correct, guys, observe this code. In this case, is front equal to rear plus 1? Rear is 4, front is 0. Is front equal to rear plus 1? Can I say it is full given this condition? Can I say it is full given this very small condition? Remember guys, can I say when front is equal to rear plus 1, it is full based on this small condition? Because some of you, not some of you, many of you said yes. Can I say the same thing observing this? Can I say it's the exact same case scenario here? No. Guys, observe. If for full, if I'm always checking if front is equal to rear plus 1 here, front should be equal to rear plus 1 to make it full. Here, front is 0. Is 0 equal to 4 plus 1? Mathematically speaking, because your program does not understand any circular queue. That is something we have to understand. So mathematically speaking, this won't work. So you have to do something like if front is equal to something like rear plus 1 mod size, or as one of you also stated, you can also do it as if mod of rear plus front is equal to size, not equal to 0. If it is equal to size, if rear plus 1 added whatever value you get, if it is equal to size minus 1, essentially size minus 1, then you can say that yes, it is a complete full full filled queue. But this is not true in every case. What if in your case this is rear and this is front? In that case, from front you're going all the way to the queue and going back. So you can't say like mod of a rare plus first will give you some value. So you have to know and remember the code of this, guys. I'm repeating this. This is very important. Whatever I'm about to say right now, understand this very, very clearly, guys. The reason I'm stressing out on this is you guys absolutely need to know, unless you work through these functions, unless you know and remember basic functions within queue stacks and everything, you're gonna find it very difficult to solve interview questions where they ask, given a small function, they ask you to point out which statement is wrong and correct it. You're gonna find that to be very difficult. So make sure you remember all the basics, that is all the functions of stacks, queues, linked lists, binary search trees, everything before you solve this. Because you can't unless you remember those. So this is something I will give you guys to do. I will not go through these. I will leave it up to you guys to do to begin with. Now, instead, we'll move ahead directly to the concept called linked lists and what sort of questions you guys can expect in linked lists. Now, you guys know that linked lists are based on a condition where memory is stored in a non-continuous allocation. Memory are not stored in a continuous allocation like an array. So if I have my first element with a value 10, it's going to store second element address there. In the second element address, you're going to have a second element, let's say 20, with address, let's assume 3000. And there in 3000, you're going to have, let's say, the third element, which will be something like 30, which may have, which if is the last element, you're going to have null at the end of it. This is basically how your entire linked list will look like. Now, I'll ask you guys just one question. Answer this as quickly as possible. Which takes more time here? Inserting an element or deleting an element or accessing elements? Which takes more time? Inserting and deleting or accessing elements? Take less than a minute, but guys, let me know. Yes, by default, accessing elements are tougher because if you want to go to the last, if you want to go to the index number 3, you have to go to first element, find address of second element. From there, go to its next address, find its address. From there, go over there to 3000. Find the next address. Wherever you get null, that is where you're finding the last element. If you want to find third element exactly, you have to go to first to last, first to second, then second to third. You have to go through one element at a time to go to some element number. So this is the difficult part in this. But the interesting part here is, let's say you have 10, the value. Let us assume it is stored in some address 1000. And let's say along with 10, it is storing, let's say, an address 2000. In 2000, let's say you have 20 and it is storing something like 3000. Let's say in 3000 again, let's say you have 30, which is storing next element as null. Now the advantage here is, you guys need to know, inserting and deleting are easy. Some of you said deleting and inserting will be difficult. I'll tell you why. See, let's say I want to insert 15 in between. If I want to insert 15 in between, here's what I'm going to do. First element is pointing to second element 2000. Instead, I will make sure if 15 is in some address, let's say 1500, I'll make sure first element, instead of pointing to 2000, is pointing to 1500. And second element, whatever is 1500 now, that will new element that will point to 2000. So now 10 is pointing to 1500, 1500 pointing to 2000. So like this, I can easily change or easily add an element. If I want to delete an element, if I want to delete this, I'll just make sure 10 points to 2000 instead of 1500. Now it will directly point to second element. So this is how inserting and deleting an element is much easier in a linked list. If you compare back to arrays, in arrays, inserting and deleting were very difficult, which took big O of n. Accessing took big O of 1. Now in linked list, it is the very opposite. Accessing will take big O of n. Inserting and deleting will generally, we call it as big O of 1. So this is the basic scenario you should know about linked list. That is, whenever we insert or delete elements, we by default take it as big O of 1, and whenever we are accessing, we take it as big O of n. Now, if you are given a question like a code for postfix evaluation, let's say you're given a code for postfix evaluation, and you need to evaluate a postfix expression, let's say something like 2 3 multiplication. So they will give you a code of it. The reason I'm taking postfix particularly is because it has less lines, somewhere around 7 to 8, or somewhere around 8 to 10 lines of code is all you have in postfix evaluation. So you may expect a code of this, and they will ask you which line has an error in it. So you need to know how to solve this postfix expression evaluation and figure out what is wrong in that code. Likewise, you can also expect a code of, let's say, a binary search tree, and insert element into binary search tree, and you should be able to figure out like whether you're able to insert an element or unable to insert an element using the code if there is something wrong. So these are some questions you may expect. Now, before we start with coding in linked list, you guys need to know three things. One is dynamic memory allocation. Another is pointers. And another most important part is structures. Now, without these basic concepts, you cannot perform or you cannot create any data structures. This is one basic thing you guys need to know. To create any data structures, you need to know these three concepts. Now, here's the thing, guys. Are you guys good at these three? Or do you guys feel like these may be slightly difficult? Because this is very important, whatever I'm about to ask. Are you guys good at these, or do you guys feel like these may be difficult? You guys let me know, because based on your answer, I will provide an assignment accordingly. If you're good at this, I'm providing one assignment. If you're difficult at this, then I'm providing a different assignment, so that we get to make sure that by the next session we are all good at the good to solve the interview questions. So some of you find some of these as difficult. Here's the thing, guys. Whichever you find difficulty in, go online, go through any article on DMA or basics of pointers or structures, and try to understand it. And what we are going to do in the next part is have a program. I'm not going to implement it. I'm just going to copy it and paste it because we want to save time. I'm just going to copy and paste a complete program of linked list, and we're going to use that to solve programs like, if given, point out errors or evaluate postfix expression. Now, before going for this, I will ask one more question. When we start with linked lists, Do you guys want me to take an example of linked list code? Like just show you guys how it works to insert an element so that you also have a brush up on how these functions work. Do you guys want me to take a small function of it as a revision so that we can brush up on it, or should I directly take the code and go for a postfix expression? You guys need to let me know right now, because based on that we're going to go for the next part. So as many of you guys possible, I need the response for this. All right, to brush up on this, first let me ask you guys, in every variable of a linked list you have two values. One is a number, another is an address. Now we know that there is no primitive data type which can store a number and address together. There is no primitive data type at all that stores number and address together. So we need to create our own data type for it. So this is where we end up creating our own data type called struct node or struct element or whatever you want to call it. So this struct node will have two values. One is an integer value, another is an address. Now here's the thing you guys need to know. Let's assume there are two elements. You have 10 and 20, which is pointing to, let's assume this is our last element. It is pointing to null. This is in address 2000. This is in address 1000. Now, the first element I can easily say it's an integer and I can call it as an int data or something like this. Now, what about the second element? It's an address. But what is this address pointing to? Let me ask you guys. Is this address pointing to only 20, or is this address pointing to the whole data here? You guys let me know. Is this address 2000 pointing to only the integer 20, or is it pointing to the entire variable, entire custom variable that we have created, which is storing an address as well as a variable? What is it pointing to? Okay, for those who say only 20, remember, if it points to only 20, how will we get the next address? It should always point to entire variable. So for it to point to, if it were only pointing to integer, I can call it as int star pointer. I can call it as int star pointer, but it's not pointing to only a pointer. It's pointing to a different data type. It's not pointing to just integer. It's pointing to this whole value, which is supposed to be of type struct node. So this is why I will create a pointer called struct node star. We'll call it as, let's say, next, for example. So in this case, you're having a data variable integer and a struct node pointer which points to another struct node element. This is our custom data type that we have created. It is pointing to another struct node element which is storing the same data. So this is your basic element. How this is your data type by which we are going to create the data structure of linked list. Now that we know what is the data type, you can now just take your C program, let's say for example, and create this data type over here, like struct node and int data and something like struct node star. We'll call it as next, because generally each variable will store address of next variable. Each variable is storing address of next variable. So that is why I'm just going to call it as next in my case. Now that this is done, for us to start with the next part, you guys need to know a few things. The few things you guys need to know are: one, learn how malloc works. If you have forgotten this, just go online, search, and find out how exactly malloc works, and search how calloc also works. These are a couple of things you guys need to know. After finding how malloc and calloc works, the next thing you guys need to know and remember very well before we start our linked list program is how double pointer works. Double pointer works in functions. So these are the two things I need you guys to go through by evening session. So just learn how malloc works, how calloc works, and how double pointers work in functions. Can you guys do this by the evening session? So that will make our programming work easier here as well. All right, guys. So make sure you do this today in our evening session. Once we start with linked list, we're gonna directly go for interview questions only in linked list. And I want to start the next concept, particularly that is called binary search trees, because this is what I expect is hugely important, equally important to hashing. So I expect these two to be most important. Then again, they may swerve and ask questions only based on linked list. They may just, you never know. But these are the most common ones asked. So we're gonna work on these in the coming sessions. Before that, we have to complete linked list. So make sure you guys go through those malloc, calloc, and how double pointers work when you send data through functions. If you've understood those concepts, we can quickly do our code and start with interview questions on these. So we'll end our session here, guys. We'll catch up in the evening. We only worked with basics of space and time complexity till now. We did not work on a lot, and we just started working with stacks and queues. We started learning what kind of um, entire data structures in stacks and queues. You have it as I'll just call it as DSA lecture 1. So we just learned how stacks and queues work, and we just learned the time complexity in stacks and queues. And we just learned how time complexity works in linked list as well. But we are yet to go through a few programming questions, which we'll do today, later on. Okay, so we'll catch up in our next session. Have a good time until then, guys. All right, thank you. Thanks a lot.